Our project is precision flying and modeling of indoor environments using the DJI Tello drone.
What we have here is a node that interfaces with the Tello using the ROS network. The ROS stands for Robot Operating System, which allows us to interface with the DJI Tello API. Using this, we're able to send movement data over to the DJI to have more precise movement.
We also used a neural network-based image detection library, YOLO V8, to do segmentation processing for detecting separate different classes within our camera. Using the DJI Tello interface and the API, we're able to get camera data, and with that, we can use monocular point localization to help get position, estimation, and orientation based off of a point map created using a single camera. Using the point cloud, we can create a 3D map of the indoor environment, allowing for better navigation.
Here we have the drone flying through a novel indoor environment generating a point cloud. Using the class data from the YOLO neural network, we'll be able to take into account obstacles and foot traffic to optimize indoor pathfinding.
The impact of our project is two-pronged. Firstly, we're creating an accurate 3D model of indoor spaces through the generation of point clouds. This model serves as a foundational data set for development of future indoor and navigational tools, which can be both invaluable to machines and people in enhancing their indoor navigation experiences. Ultimately, this will contribute to the development of tools that increase accessibility of indoor spaces for everyone. Secondly, our project also has a profound impact on autonomous vehicle traversal. Leveraging the point map and the data produced by the YOLO network, we are able to develop more advanced pathfinding tools for autonomous vehicles, which take into account the surrounding environment and obstacles, leading to improved safety and efficiency in indoor autonomous navigation.